All right, so all of these would be pretty much the basic level of target 8 solving quadratic equations by the three methods. So just solving them by factoring. These are already in equal zero form, so you don't have to worry about that. You just have to choose the most appropriate factoring method. So in this case, we have a leading coefficient of 1, which means we need two numbers that multiply to negative 24 and add to 2. So positive 6 and negative 4 are what go in the factors, but don't confuse factors with solutions. The solutions are the values that make each factor equal to 0. So negative 6 makes the first factor 0, and positive 4 makes the second one 0. And you can check these by plugging them in. If you take 4 squared plus 2 times 4 minus 24, you will get 0. 16 plus 8 minus 24 is 0. For part B, we have not a leading coefficient of 1, but it starts and ends with a perfect square. So if we square root the start, square root of 4x squared, we get 2x. And the square root of 9 is 3. And if we multiply 2x and 3 together and double, we do get the middle term, although it's negative. So if we make them both negative factors, then that's our correct way to factor. And this is what's called a double root, or double solution, because it's the same solution twice. If we solve 2x minus 3 equal to 0, we would simply be adding 3 and dividing by 2. So our solution would be positive 3 halves, or 1 1/2. And again, that's a double root, or double solution. For C, there's only 2 terms. Remember, the first rule for factoring is to take out a GCF. So if I factor out the GCF of 2x from each of those terms, so I'm dividing 6x squared by 2x to get 3x, dividing 4x by 2x to get 2, now it's in factored form. This factor equals 0 when x is 0. This factor equals 0 by subtracting 2 and dividing 3 when x is negative 2/3. I'm going to jump to E. E is another perfect squares. Square root of 9x squared is 3x. Square root of 25 is 5. But you'll notice there's no middle term. There's 0x in the middle if you wanted to write it in there. So to make the middle terms add to 0, we need 1 plus and 1 minus. Our outer would be negative 15, and our inner would be positive 15x. Those would cancel. So our two solutions, we solve this one equal to 0 by subtracting 5 and dividing by 3. We get negative 5/3, and the other one is positive 5/3. Or as you could say, plus or minus 5/3. Now you saved D because for D, I would use the box method. There's not a leading coefficient of 1. It's not a perfect square. Can't factor out any GCFs. So we're going to start by putting our first term in that corner and our second term in that corner, and find two things that add to 17 and multiply to this product. The multiply product is negative 60x squared. And we need them to add to a positive 17. So I'm thinking a positive 20x and a negative 3x. Those multiply to negative 60, and they add to 17. So I put those in the other two corners. So we have negative 3x and 20x. And then it's just factoring out the GCF from each row. Check by multiplying. Nope, something isn't right. I can take a 4 out of those, not a 2. That looks good. So the factorization is 4x minus 1, this is a 4 here now, times 3x plus 5 equals 0. So this factor is going to equal 0. Subtract 5, divide by 3. When x is negative 5/3, this factor equals 0, add 1, divide by 4, you get 1/4. So when we're solving by factoring, we have to get the equals 0, and then we have to factor it, and then we solve each factor equal to 0. And as you can see, I just did those 5 problems pretty quickly. It does go pretty quick when you have factorable ones, and you're pretty decent at factoring. The next 2 problems are using square roots, and this method goes pretty quick and is pretty good when this works. But remember, this only works if there's only an x squared term, or something squared like in part B. If you were to expand part B to x squared plus 8x plus 16 by doing x plus 4 times x plus 4, now it has x squared terms and x terms, and you can't use square roots anymore. But if you leave it in the form that it's in, you can use square roots. So our goal is just to get x alone. Isolate x. Or first you have to isolate what's being squared, which in this case is x. So I would subtract 33, you get negative 9. I would divide by 12 and simplify. Negative 9 divided 12 reduces to negative 3/4. And then lastly, you square root. So you get x equals plus or minus the square root of negative 3/4. Now we're not going to leave our answer that way. Now we're going to apply target 7 ideas to simplify those radicals. So the first rule is we can't have a negative. So I would first change this to I times the square root of 3/4. Because remember, the square root of negative 1 is I, so it's an imaginary number. Then I'm going to rewrite it as square root of 3 over square root of 4, because there's a rule that says you can't have a radical in the denominator when you simplify it. And in this case, the square root of 4 is just 2. So it's plus or minus I times the square root of 3 over 2. So positive I square root of 3 over 2 and negative I square root of 3 over 2. The other one with square roots, again, you have to leave it in this form to be able to use square roots. So you're isolating the thing that's being squared, which in this case is the x plus 4. So I'm first going to undo the multiplication by division. Remember, we're undoing in reverse order of operations. Negative 48 divided negative 2 is positive 24. Then I'm going to undo the squared by square rooting, because I'm saving for what we would do first, which is what's in the parentheses, to undo last. So I get x plus 4 equals, don't forget your plus or minus, square root of 24. I'm going to simplify that. To simplify a radical, remember you have to factor out any perfect squares. So 4 is a factor of 24, and it's a perfect square. So the square root of 24 can be thought of as square root of 4 times square root of 6, which is 2 square root of 6. So I'm going to change this to plus or minus 2 square root of 6. And then I'm going to finish solving for x by subtracting 4 after that. And I'm going to put the 4 first. So I have a negative 4 plus or minus 2 square root of 6. So there's 2 solutions here, negative 4 plus 2 square root of 6, and negative 4 minus 2 square root of 6. And you can leave it just like that. The last method is the quadratic formula. And we could use the quadratic formula for any of the problems that we did in numbers 1 and 2. It always works. But the trouble is it takes a little longer sometimes. So I'm first going to get it in standard form. Remember, if there's no coefficient, it's a 1. I'm going to add 9 to both sides to get equals 0. So now it's in standard form. I can identify my A, my B, and my C, which are the coefficients in standard form. And then I'm going to plug it in to the quadratic formula in place of the correct letters. So I'd have negative 1 over 2 times 2. So I'm replacing B with 1 and A with 2, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. And I'm going to clean this up a little. So it'd be negative 1/4, plus or minus something over 4. And let's see, what's 1 squared minus 4 times 2 times 9? What I usually do is I just type this part, the part that's underneath the radical in my calculator. So if I type that in, I'd multiply first to get 72 here. 8 times 9 is 72. So 1 minus 72 is negative 71. And the only thing we need to do to clean that up, there are no perfect square factors of 71, but we do need to take out the I. So it's I squared root of 71 over 4. So here's our two answers. Again, our answers are complex conjugates. There are no real solutions. The solutions involve imaginary numbers. Any questions on those?